Hi and welcome back to Gaffy's Grinds. In this video, we are going to be learning about how to measure the rate of a chemical reaction. Before we begin, usual reminders that try and eliminate any distractions now by sticking your phone onto do not disturb mode, close any open tabs, especially social media, and make sure you do the questions when I ask you to do them. Okay, so in our previous lesson, we learned about what rate of reaction means. So just taking an example, say we have a chemical reaction where we've got reactants A and B reacting together to give us product C plus D. What rate of reaction means is just how quickly or how slowly is this chemical reaction happening. So we looked at some reactions that happen very quickly, for example, an explosion, and other reactions happen very slowly, for example, rusting. Now, what if we want to measure the rate of a reaction? Okay, so measuring the rate of the reaction. Okay, so obviously, sometimes we can tell by just looking if a reaction is happening very quickly or very slowly. Well, if we want to actually measure the rate, okay, we're going to have to be a little bit more specific than that. So measuring the rate of a reaction. So how would we go about this? Okay, well, generally, if we want to measure the rate of a reaction, we're generally going to need to ask a question: how quickly, I'm going to look at two things. We can measure either how quickly are the reactants being used up. So if we can find a way of measuring how quickly the reactants are being used up, then we can measure how quickly the reaction is happening. So if we can measure how quickly A and B are disappearing, because remember A and B are turning into C and D, then we can find out how quick the reaction's happening. So we might do this by measuring how quickly the mass is reducing of, like, if we put a certain mass of two reactants into a flask, and maybe they make a gas, so the gas evaporates. And if we can measure the mass, how quickly the mass is changing, then we know that the reactants are getting used up quickly. A more common way of doing this is to measure how quickly are the products being formed. So how quickly are products being formed? So that might involve, like, if we're making a gas, we might collect the gas and find out how much is being formed and how quickly it's being formed, something like that. So that's generally what we want to do if we want to measure how quickly the rate of a reaction is happening. We either want to measure the products being formed and how quickly they're being formed, or measure how quickly the reactants are being used up. And we can use a graph to show the rate of a reaction. So what I'm going to do is I'm going to plot an X and a Y axis. So this is my Y axis. And I'm going to draw an X axis as well. Okay, and on my X axis, I'm going to put time. So this is as time proceeds in the reaction, and time is measured in seconds. On the y-axis, and there's a couple of ways you can label the y-axis. It depends what you're measuring, but generally we want to measure something called a concentration. We've seen concentration before. It basically means how much of something that there is. Okay, so it might be in grams per liter. It could have a different unit depending on how you're measuring it. But concentration generally refers to just how much of the thing that you have. If you have a high concentration, that means you have a lot of the substance. If you have a low concentration, it means you don't have much of the substance. Okay, generally, in a rate of reaction, we're going to get a curve. Okay, so I'm going to draw a curve here, which is going to show products being produced. So in the beginning, there are no products. So this blue line is going to show what happens to the products as the reaction proceeds. So here, I am increasing the concentration of the products as time goes on. And it's increasing very, very quickly all the way up until it slowly starts to level off. And eventually, the concentration stops changing. This line shows how the products change in a chemical reaction. Products change. All right, let's just quickly label this line. Here, we have a line that is increasing. The concentration of products is increasing. And this shows us that products are forming. Products are forming. Now, obviously, at the beginning of the reaction, there's no product, so you don't have any. So that's why it starts at 0. Products form as the reaction goes on, so the amount increases. Now, let's talk about the speed at different parts of the graph. If we were to draw a tangent, which is a line that kind of runs along the graph at a certain point, if we were to draw a tangent at the beginning, this tangent here shows that the rate here is extremely fast. So this is the fastest rate because the graph is steepest here. So the fastest rate is at the beginning of the reaction. If I was to draw another tangent here, where the curve starts to change, here is a second tangent. This tangent shows that the reaction is slowing down, so it slows down. So I have a slightly lower rate of reaction just here than I did in the beginning. It slows down. So the fastest rate is in the beginning and the slows down here. Okay, here you can see that actually there is no more, the concentration isn't increasing at all anymore, which tells me that the reaction has stopped. It's made all the product that it's going to make now. It's not going up anymore. So the reaction now has stopped. The graph has leveled off. So that is how we can track the amount of product formed over the course of a reaction. In the beginning, there's none and it increases. And in the beginning, it increases very quickly, shown by the steep graph. Then it levels off. And as it levels off, we say the rate of reaction is slowing down. It's not as fast as it was. And then the reaction actually stops. So the rate is now going to be 0 on the flat part of the graph. We could also look at how the reactants change. So the reactants begin up here with the red line. The red line, in the beginning, the concentration of reactants is high. Concentration is high because we're starting with all of reactants. And over time, the amount of reactants we have, goes down. I'm just going to make this a little bit thicker line. The amount of reactants we have goes down, and it's going down very quickly in the beginning. And slowly it starts to level off until eventually we've got no reactants left. Okay, so what does this show us? Well, first of all, we see that we have a line that is decreasing. Decreasing. What does this tell me, the decreasing line? This tells us that reactants are getting used up. Reactants are used up because the concentration is going down. Now, note that on this y-axis, we could also be measuring in grams. So a mass in grams, and it will be the same thing. The reactants will be going down in grams and the products will be going up in grams. We could be measuring volume, which is like an amount of gas or an amount of liquid when you measure it in centimeters cubed. And again, there would be no volume of the products in the beginning, and it would go up as the reaction goes. And we would have a high volume of reactants in the beginning, and it would go down as the reaction goes on. Okay, so products are always going to start at 0, and reactants are always going to start at a high number and go down to 0. All right, it's the same thing. Okay, this here in the beginning of the reaction here, this shows me the fastest rate. All right, now here is where the rate of reaction starts to slow down as the curve levels off. And then down here, this flat line is where the reaction has stopped. And this shows me reactants. That is the reactants. All right, so what I'm going to get you guys to do now is I'm going to get you to pause the video and I'm going to get you to take down what I have on the screen there. So take down that graph, a sketch of that graph. Try and use a different color to show the reactants and the products. It's a good idea. And this is how we measure the rate of a reaction. All right, so pause the video, do that now. Okay, time to do some practice. Here we are. We're going to start with questions 1, 2, and 3. So what you've got to do is you've got to select which is the correct answer. So each of these first 3 questions has 3 choices of the answer, and you have to select which one is correct. So write down the correct one. So pause the video, do that now. Okay, so first of all, rate of reaction can be measured by how quickly that would be both of the below. Because it can be, we can measure how quickly the reactants are used up or how quickly the products form. Both of these are true, so we say both of the below. Rate of reaction can be measured by how quickly both of these things happen, reactants used up or products formed. As the concentration decreases, the graph is showing what? So as the concentration decreases, the graph is showing that would be the reactants being used up. Okay, so that's like this line over here. Let's have a look again. This line over here. Okay, this line shows the concentration decreasing. This shows the reactants being used up. Okay, so that's that one, number 2. Well done. If you got that right, good job. Tick it. If not, you need to fix it. The fastest rate is at, okay, so hopefully here you said the steepest part of the curve. So the steepest part of the curve shows that it's changing at the fastest rate. So that shows us that the rate is highest there. Well done, if you got that right. All right, let's take a look at this one, okay? You should actually be able to do the rest of these. So I'm going to get to pause the video. I'm going to get you to use the graph here to answer some of the questions and finish it off down to the bottom. Okay, so you should only be watching now if you have done question 4, 5, 6, 7, and sorry, there's actually 2 number 5, so it should be 4, 5, 6, 7, 8, and 9. Sorry about that. Hopefully I might be able to get that fixed now. 6 down. All right, you get what I mean. Anyway, that's 7, that's 8, and that's, sorry about that. Okay, so number 4. Which letter shows the early stages of a reaction? Okay, hopefully you said A. A is the early stage. Down here, the reaction has just started. The products are just forming. So it's got to be A. How do you know? Well, not a lot of product has been formed. Not a lot of product has been formed. So it's got to be early. The reaction hasn't been going on too long because we haven't got much product yet. Which letter shows that the rate of reaction is 0 or the reaction has stopped? Hopefully you said C. Well done. If you said C, those are all correct so far. How do you know? Well, we know because the concentration obviously is still, it's not moving anymore. So that means the reaction isn't happening anymore. So the reaction is over. Okay, so we say, how do we know? We know this because no more product is being formed. No more product has been formed. You might have also said like the concentration of the product is not changing anymore. No more product is being formed. Well done, if you got that right. Next one, describe what happened to the concentration as time passes. So you have to describe, using words, what happens to the concentration of the product as time passes. So break it into little sections. All right, so maybe we'll explain as the first bit of time passes. So from this much time has passed, what's happened here? Then break it into, okay, another bit of time goes by, what happens here? And then the rest of the time, what happens? So if you didn't break it into 3 stages like that and go, okay, in the beginning, next, and then last, that's what you should do, okay? Break it into 3 bits. So you haven't really, if you've just said it goes up, that's not really going to be specific enough. So have another go, but be a bit more specific. Describe what the graph actually shows you. Okay, so do that now if you haven't already done it. All right, so describe. So let's describe what happens. So at first, the concentration increases rapidly or very quickly. Okay. It then stops, or it then slows down increasing or increases more slowly. Yeah, so probably better if we say it then increases more slowly for a little bit of time. It then increases more slowly. And we then say, then it finally stops changing or stays flat, stops changing. That's what we're talking about, the concentration here. Remember, this is the concentration. In the beginning, it's going up very quickly. Then it goes up a little bit more slowly, and then it stops changing. Right, last one. Describe what happens to the rate of reaction as time passes. Describe what happens to the rate of reaction. Okay, so at the rate of the reaction in the beginning, this rate here, we would say this rate is very fast. It is then slower, and then it stops. Okay, so in the beginning, so at first, the rate is very fast. We would then say what happens to it. It then slows down, and finally, it finally goes to zero. It stops changing. It stops. The rate goes to zero. Okay, it finally goes to zero, or it stops. All right, guys, that's it. That's how we measure the rate of a reaction. We measure the how the concentration or the amount of reactants changes over time, or how the amount of products changes over time. So how the amount of reactants reduces, or how the amount of products increases. That's what we want to measure, and how quickly it's changing. That's it, guys. I'll see you in the next video. Thanks for joining. Leave us a like if you found this easy to follow. Thank you.